So, good morning, dear students of IT 6203, Database Management System 2. So, I am Ms. Karen V. De Lara, your OLC for this course. I am from AMA Computer College, East Rizal Campus. So, welcome to our virtual class today. So, for today, we will be reviewing the following or discussing the following. So, what is SQL? Applications of SQL, brief history of SQL, SQL syntax, importance of or important SQL commands, and syntax in SQL. So let us first define what is SQL. So SQL stands for Structured Query Language, a database computer language designed for the retrieval and management of data in a relational database. So SQL is a language to operate databases. It includes database creation, deletion, fetching rows, modifying rows, and the like. SQL is an ANSI or American National Standards Institute standard language, but there are many different versions of the SQL language. So what are some of the applications of SQL? So number one, it allows user to access data in the relational database management systems. It also allows user to describe the data, allows user to define the data in a database and manipulate that data, allows to embed within other languages using SQL modules, libraries, and precompilers, allows user to create and drop databases and tables, allows user to create view, stored procedure, functions in a database, and lastly, allows user to set permissions on table, procedures, and views. So here is a brief history of structured query language. 1970, Dr. Edgar F. Ted Codd of IBM is known as the father of relational databases. He described a relational model for databases. 1974, structured query language appeared. 1978, IBM worked to develop Codd's ideas and release a product named System/R. 1986, IBM developed the first prototype of relational database and standardized by ANSI. So the first relational database was released by Relational Software, which later came to be known as Oracle. So now we will be discussing various SQL syntax. So SQL is followed by a unique set of rules and guidelines known as syntax. So all the SQL statements starts with any of the keywords like select, insert, update, delete, alter, drop, create, use, show, and all the statements end with a semicolon. So the most important point to be noted here is that SQL is case insensitive, which means select with a capital letter and select with the lowercase letters have same meaning in SQL statements, whereas MySQL makes difference in table names. So, if you are working with MySQL, then you need to give table names as they exist in the database. So here are some of the list of important SQL commands. So number one, we have select, which extracts data from a database. Update, updates data in the database. Delete, deletes data from a database. Insert into, inserts new data into a database. Create database, creates a new database. Alter database, modifies a database. Create table, creates a new table. Alter table, modifies a table. Drop table, deletes a table. Create index, creates an index or search key. And drop index, deletes an index. So now let's discuss some of the syntax in SQL. I have provided the structure of the statement of SQL and some examples. So the SQL select statement is used to fetch the data from a database table, which returns this data in the form of a result table. So these result tables are known as result sets. So the syntax is select space column 1, column 2, column n from table name. So here, column 1, column 2, and so on and so forth are the fields of a table whose values you wanted to fetch. So if you want to fetch all the fields available in the field, then you can use the following syntax. Select asterisk from table name. So this particular syntax is used if you want to display all the fields or records in the table. So I have here an example of a customer table having the following records. So we have 5 columns. The first one is the ID, the name, the age, the address, and the salary. So we will use this table for the entire class. So we have 7 records inside the table. So again, which consists of ID, the name, the age, address, and salary. So the following code is an example which would fetch the ID, the name, and salary fields of the customers available in customers table. So given the table customers, so we have the column ID, name, age, address, and salary. So we will be using the syntax select ID, name, salary from customer table. So since we are going to use the same table, so we will fetch the the data such as ID, name, and salary. So to produce, the produced output will be the ID. We will fetch the column ID, the name, and the salary. Okay, so a specific fields are only selected in the table. Okay, so if you want to fetch all the fields of the customers table, then you should use the following query. Select asterisk from customers. So from the previous example, we only fetch a certain fields, but in this particular example, if you wanted to display all the data inside the table, so we will be using asterisk. So it displays the ID, the name, the age, address, and the salary. So next is the SQL where. So the where clause is used to specify a condition while fetching the data from a single table or by joining with multiple tables. If the given condition is satisfied, then only it returns a specific value from the table. You should use the where clause to filter the records and fetching only the necessary records. So the where clause is not only used in the select statement, but it is also used in the update, delete statement, which we would examine in the subsequent chapters. So we have here the syntax. So select column 1, column 2, and column n from the table name where condition. In the condition, you may use operators such as, for example, greater than, less than, greater than equal, less than equal, equal, or not equal. So the following code is an example which would fetch the ID, the name, and the salary fields from the customers table where the salary is greater than 2,000. So we are going to fetch the name, the ID, and the salary fields or the amount of the salary from the original table, the given condition. So we have select ID, So we will be using this particular SQL statement. So select ID, name, salary from customers. So that is our table name where salary is greater than 2,000. So we are going to um, determine which particular employee has a salary of greater than 2,000. So we have number 4, Chaitali, which is 6,500. And then we have Hardik, which is 8,500. And we have Komal, 4,500. And Mafi, which is 10,000. So our statement will produce the output ID 4 for Chaitali, 5 for Hardik, 6 for Komal, and 7 for Mafi. If, for example, we are asked to get the salary which is greater than equal to 2,000, then we will add Ramesh. But in this case, our condition is where salary is greater than 2,000. So that's why Ramesh is not included in the output. Okay. Next, the SQL and or operators. So they are used to combine multiple conditions to narrow data in an SQL statement. So these two operators are called as the conjunctive operators. So these operators provide a means to make multiple comparisons with different operators in the same SQL statement. So the AND operator allows the existence of multiple conditions in an SQL statements where clause. So our syntax is select column 1, column 2, column n, where from table name where condition and condition. So here is an example. So we will fetch the ID, the name, and salary field from the customer's table where the salary is greater than 2,000 and the age is less than 25 years. So basically, the condition here that we are going to satisfy are two. So we are going to get the salary which is greater than 2,000 and the age must be less than 25 years old. So given the same table or the customer table, so our produced output will be 6 Komal, which is 22 years old, which has a salary of 4,500, and 7 Mafi, which is 24 years old and has a salary of 10,000. So we have satisfied the condition that the salary is greater than 2,000 and age is less than 25 years old. So for the rest, it will not be generated by the statement because they did not satisfy our condition. Okay, so next we have the OR operator. So this is used to combine multiple conditions in an SQL statements where clause. So our syntax is select column 1, column 2, column n from table name where condition 1 or condition 2 or condition n. So it has the same format of the syntax of the AND operator. So the following code block has a query which would fetch the ID name and salary fields from the customer's table where the salary is greater than 2,000 or the age is less than 25. So our statement will be select ID, name, salary from customers where salary is greater than 2,000 or age is less than 25. So we will be producing or the output 3, Kaushik, which is 23 years old, salary is 2,000. Okay, and then we have number 4, Chaitali, which the age is 25, and then 6,500, Hardik 8,500, Komal, and Mafi. So in this generated output, we are just going to display the ID, the name, and the salary of a particular customer. Okay, next we have the SQL update. So this query is used to modify the existing records in a table. You can use the where clause with the update query to update the selected rows. Otherwise, all the rows will be affected. So our syntax is update table name set column 1 is equal to value 1, comma, column 2 is equal to value 2, column n is equal to value n, where condition. So this particular SQL statement, so we uses the keyword where to specifically display the conditions that we would like to satisfy. So the following query will update the address for a customer whose ID number is 6 in the table. Okay, so we have the SQL statement update customers, set address is equal to Pune where ID is equal to 6. So basically, um, the syntax here is set column 1 is equal to value. So we are going to indicate what particular value are we going to indicate in our updated table. And to specifically determine which particular customer we are going to update is we are going to indicate the conditions here. So in our statement, where ID is equal to 6, so we are going to update the record number, ID number 6. So if you can see in the produced output, Komal, previously the address is MP, and now we change it to Pune. Okay, so that is update. So we can change the value of a particular records inside our table. So like for example, if you wanted to change the address of other employee, you can provide here in the statement another set value. Okay, so next we have the SQL delete query. So this is used to delete the existing records from a table. So you can use the where clause with the delete query to delete the selected rows. Otherwise, all the records would be deleted. But we have to be very careful when using the delete query or the drop table. So we have to use it with we have to be aware of how it will affect our database and records. So the syntax for the delete is delete from table name where condition. Okay, so we have the following code has a query which will delete a customer whose ID is 6. So we are going to erase the ID number 6. So we are going to delete all the records of the customer whose ID is equal to 6. So we have delete from customers. So this is, again, the customer is our table name where ID is equal to 6. So this is our original table. So we have 1, 2, 3, 4, 5, 6, 7. 7 records in the customers table, and in the produced output, so we already deleted number 6, Komal, 22 MP 4,500. So after customer ID 5, Hardik, so it follows customer number 7, Mafi. So that's how we delete a particular record inside our table. Okay, next, the SQL like clause is used to compare a value to similar values using wildcard operators. So there are two wildcards used in conjunction with the like operator. So we have the percent sign and the underscore sign. So the percent sign represents 0, 1, or multiple characters, and the underscore represents a single number of character. So these symbols can be used in combinations. So these are the syntax in using the percent sign and the underscore sign. So we have select from table name where column like, so you can use the percent symbol after the values, or select from table name where column like, so you can use 2% sign in between your value, or select from table name where column like value and then underscore, or select from table name where column like underscore and the value. Okay, so next, following is an example which would display all the records from the customer's table where the salary starts with 200. So let's use the SQL statement select asterisk from customers where salary like 200% sign. So since we use a select asterisk, so it will display all the values inside all the columns inside the table. So, but the SQL statement will only fetch those values that will satisfy our condition salary like 200%. So which is which? So we have one Ramesh, 2000, and then ID number three, Kaushik, which is 2000. So that is our output. So we have customer number one, Ramesh, 32, and then customer number three, Kaushik, age 23. Okay, so next, syntax in SQL. So the SQL order by clause is used to sort the data in ascending or descending order based on one or more columns. So some databases sort the query results in an ascending order by default. So what is our syntax? So we have select column list from table name where condition order by column 1, column 2, column n, and indicate if it is ascending or descending. So the following code block has an example which would sort the result in an ascending order by the name and the salary. So we have the SQL statement select asterisk from customer, which is your which is your table name, order by name and salary. So in the original table, so if you can see, it is not arranged whether ascending or in descending order. But in the produced output with the use of this SQL statement, we have number 4, Chaitali, and then number 5, we have Hardik. Number 3, we have Kaushik. Number 2, we have Kilan. Number 6, we have Komal. Number 7, we have Mafi. And number 1, we have Ramesh. So the names are um, arranged in ascending order. So that is A to Z. Okay, so but of course, we also indicated their name, their address, and their particular salary. Okay, so next, the following code block has an example which would sort the result in the ascending order by name. So we are going to arrange the name of the customer by descending order. So using the SQL statement, select asterisk from customers, order by name descending. So again, using this SQL statement, so we are going to use, or we are going to display all the values or all the fields in the table because we uses the select asterisk. Okay, so to arrange this in descending order, so basically we will start with Ramesh, ID number 1, and then followed by Mafi, ID number 7, Komal, ID number 6, Kilan, ID number 2, and then we have Kaushik, and then Hardik and Chaitali. So the names are arranged in descending order. Okay. So next we have SQL Joins. So this clause is used to combine records from two or more tables in a database. So a join is a means for combining fields from two tables by using values common to each other. So this is used if we wanted, for example, to join common values in the table. So several operators can be used to join tables such as equal, less than, we also have greater than, less than equal, greater than equal. We can also use not equal. Not equal is represented by an exclamation point and an equal symbol. And then we can also use between, like, and not. So for the join clause, we will be using table 1 as customers table, which contains ID, name, age, address, and salary fields. And then we have the table 2 orders table, which contains order ID, the date, the customer ID, and the amount. Okay. So let us join these two tables in our select statement. So we will be using the statement select ID, name, age, amount. Okay, so we will be displaying this one, ID, name, age, amount from customers. Okay, so this is our table 1. And orders, this is our table 2, where customer ID is equal to orders dot customer ID. Okay, so we have customer ID 3, which is Kaushik here in the table 1, whose age is 23 and the amount is 3,000. So that is our first output. So another is customer ID 3. Again, we have Kaushik and then 23 and then 1,500. And then customer ID number 2, which is Kilan, 25 and 1,560 is the amount. And customer ID 4, Chaitali, 25, 2,060. So the generated output for our SQL statement, select ID, name, age, amount from customers, orders, where customers.id is equal to orders.customer underscore ID. So our output is 3324. Okay. So next we have SQL union clause operator. So this is used to combine the results of two or more select statements without returning any duplicate rows. So to use this union clause, each select statement must have the following. So same number of columns selected, same number of columns expressions, the same data type, and have them in the same order. Okay, so the basic syntax of a union clause is as follows. So we have select column 1 or column 2 from table 1, table 2, where condition, and then we are going to use the keyword union, and then select column 1, column 2 from table 1, table 2, where condition. So let us join these two tables in our select statement as follows. So we have select ID, name, amount, and date from customers. Left join orders on customer ID is equal to orders.customer ID. Union, select ID, name, amount, and date from customers. Right join orders on customers ID is equal to orders.customer ID. So always take note of the conditions when performing the union clause. So again, the same number of columns selected, the same number of columns expressions, the same data type, and have them in the same order. Okay, so I think our SQL statement here satisfies those guidelines for conditions. So this will be our um, generated output. So again, we use the same table 1 for our customer table and table 2 for our orders table. Okay, so in our SQL statement, we use select ID, name, amount, and date. So we have ID, name, amount, and date columns. Okay, then from customers, left join orders on customers ID is equal to orders customer ID. So we have here number 1, Ramesh. The amount is null and the date is null because in this particular table, the customer ID and the ID here is not available. Okay. For number 2, we have Keelan. Okay. So number 2, we have here order ID 101. So that's why we have the date 2009-11-20. Okay. Next, for Kaushik, we have customer ID 3. So we have 3 here, customer ID, Kaushik. So the amount is 3,000 and the date is 2009-10-08. Next, we have another 3 here, which is also Kaushik here, 3, which has an amount of 1,500 and the date is 2009-10-08. Next, we have customer ID 2, which is we're done with 2. Now let's proceed with 4. So we have Chaitali 2060, which is the date is 2008-05-20. So if the customer ID in our table number 2 is not available, basically the displayed value will be null or empty. Okay. So next we have SQL null. So this is a term used to represent a missing value. A null value in a table is a value in a field that appears to be blank or empty. So a field with a null value is a field with no value. It is very important to understand that a null value is different from a zero value or a field that contains spaces. So that is different. Okay. So the syntax for our null is create table customers ID. So int, this is an integer, so not null, name varchar 20, not null, age integer, not null, then address is character 25, salary decimal 18, comma 2, and primary key is the ID. So basically, you are all doing your databases. So primary key is very important in doing our databases. So here, not null signifies that column should always accept an explicit value of the given data type. So there are two columns where we did not use not null, which means these columns could be null. A field with a null value is the one that has been left blank during the record creation. Okay, so the null value can cause problems when selecting data. So however, because when comparing an unknown value to any other value, the result is always unknown and not included in the results. So you must use the is null or is not null operators to check for a null value. Consider the following customers table having the records as shown. So we have fields ID, name, age, address, and salary. But if you can see, ID number 6 and 7 do not have an indicated amount for the salary. So now let's take an example. So the following is the usage of the is not null operator. So we have the SQL statement select ID, name, age, address, salary from customers where salary is not null. So again, what do you mean by so we are going to use the is not null operator. So to check for a null value. Okay. So for the output, we will be fetching the value ID, name, age, address, and salary from this table, satisfying the condition salary is not null. So which particular records do we have to display? So we have Ramesh, and then Kilan, Kaushik, Chaitali, and Hardik. Why? Because they have indicated the amount of their salary. So we are going to satisfy the condition salary is not null. Okay. So if we are going to use um, the statement is null, so we are going to generate the following output. So select ID, name, age, address, salary from the customers table where salary is null. So we will only display two values, which is number 6, ID number 6, and ID number 7, which is Komal and Mafi. As I have said a while ago, that the salary for these two customers or their salary is not indicated in the original table. So they satisfy the condition salary is null. So our produced output is Komal and Mafi. So no salary amount is indicated. So now, since we're done with the different, some of the basic SQL commands, so now let us try to answer the following exercises. So I have given a statement here, and you are going to provide what is missing inside the particular SQL statement. Okay, so anybody can participate in these exercises. So the first one is insert the missing statement to get all the columns from the customers table. So let's say, for example, we will be using the same table. But since we're going to use the same table, so just tell me what particular statement is missing in this particular question. So anybody can answer. You can turn on your microphone so to answer these exercises. Okay, so what is missing in this particular statement? So you are asked to get all the columns from the customers table. Anybody? So anybody, what is missing?
Select
Okay, very good. So the missing statement here is we have select. Okay, so in order for us to get all the columns from the customer table, so we are going to insert the word select from customers. Okay, so very good. Next, select all the different values from the country column in the customers table. So again, select all the different values from the country column in the customers table. So we have country from customer. So what is missing?
select value
Mm-hmm. Okay, so we have select distinct country from customers. Why are we going to use the distinct? Because we are going to indicate a what?
country.
Okay, very good. So we have select distinct country from customers. Okay, thank you. Next, select all records from the customers table, sort the result reversed alphabetically by the column CT. Okay, select all records from the customers table, sort the result reversed alphabetically by column CT. Anyone? Anyone who wants to um, answer? So how are we going to write the query for this particular activity? So select all records from customers table, sort the result, reverse alphabetically by the column CT. So we have select asterisk from customers and then blank. So who wants to
select customer
select
from
asterisk from customers?
from table ordered by
Mm-hmm. Okay, so we
city,
have, oh, so we
ordered by
have,
city.
okay, very good. So you just missed the keyword
Yes,
descending. Okay.
design.
Yes, yes. Because you have to sort the result reversed alphabetically. So, di ba? So, the answer will be select asterisk from customers, order by city descending. Okay, very good. So, next, insert a new record. So, we have select all
Ay, ma'am,
records. Yes?
ma'am, may question ako,
Yes.
ma'am. Kasi
Hmm.
nung last mo na sa yung tawag dyan, sa yung lecture mo ba, last mo na ano kasi pag alphabetically is wala siyang descend para siyang yung ordered by lang.
Um, because we are asked to have the result reversed alphabetically.
Reverse. Okay, sorry,
Yes,
sorry.
reverse alphabetically. So
Okay.
if you were asked to arrange to order it, it's automatically A to
Hindi ko
Z.
nabasa
But
yung reverse.
yes, so that's why we have the keyword descending. Okay?
Okay, ma'am.
Okay, now let's proceed. So insert a new record in the customers table. So we have blank customers, blank customer name, address, city, postal code, country, um, Heckenberger, Gatevin 15, Sandnes 4303, Norway. So how are we going to insert a new record? What particular SQL statement are we going to use? So we are going to insert a new record in the customers table.
Insert,
Hmm?
insert into
Mm-hmm.
customers, uh, values, no. Insert customers,
Mm-hmm.
in, ay, meron pa, ano. Insert values,
Mm-hmm.
um, open, close
Mm-hmm.
parentheses,
Mm-hmm. Okay.
then values, close open parentheses.
Mm-hmm. That's
Minus
it?
array. Yes, ma'am.
Okay. So, yan. Okay, very good. So, insert into customers and then parentheses for the value. So, we have customer name, address, city, postal code, country, values. So, what particular values are we going to insert into the table? So, here, here are the values. So, we have Heckenberger, Gateway 15, Sandnes 4303, and Norway. So given those values, so in our table, so those are the different fields that we are going to insert or add into the table. Okay, very good. Okay, thank you. Next, select all records from the customers where the postal code column is not empty. Okay, select all records from the customers where the postal code column is not empty. So our incomplete statement is select asterisk from customers where blank semicolon
Where postal code
is
is not null.
Daniel, okay. So,
Yes, ma'am.
okay, so our, yeah, okay, very good. So our output will be
Yes,
select
ma'am.
from, select asterisk from customers where postal code is not null. Okay, very good. So next, select all records where the first letter of the city starts with anything from an A to an F. That is a small letter A and small letter F. So we have select asterisk from customers where city like blank percent sign. Okay, so how are we going to complete this statement?
Select all from
Asterisk.
customers. Select asterisk from customers for city like
Okay.
um ano ito, kuhit sa taas tapos
Mm-hmm.
yung parang bracket ba na?
Aha, aha. Square bracket.
Square bracket
Ah,
A dash square
oh,
bracket.
ah. And then percent.
Yes po.
Okay, very good. So our output will be very good. Select asterisk from customers where city like square bracket A dash F square bracket percent. Okay, very good. So those are, thank you, John Romer, for participating in our exercises. For the rest of the students, you review your basic SQL commands. We will be discussing applying DML in subqueries and applying database view. So, what are SQL subqueries? A subquery or inner query or a nested query is a query within another SQL query and embedded within the where clause. A subquery is used to return data that will be used in the main query as a condition to further restrict the data to be retrieved. Subqueries can be used with the select, insert, update, and delete statements along with the operators like equal, less than, greater than equal, less than equal, in, and between. So SQL subqueries. So there are a few rules that subqueries must follow. So the first one is subqueries must be enclosed within parentheses. A subquery can have only one column in the select clause unless multiple columns are in the main query for the subquery to compare its selected columns. An order by command cannot be used as a subquery, although the main query can use as an order by. The group by command can be used to perform the same function as the order by in a subquery. Subqueries that return more than one row can only be used with multiple value operators such as the in operator. And the select list cannot include any references to values that evaluate to a blob, array, clob, and nclob. So blob stands for binary large object. It is a collection of binary data stored as a single entity in the database management system. Okay. And then the clob stands for character large object. It is a collection of character data in a database management system, usually stored in a separate location. While nclob is the national character large object, it is an Oracle data type that can hold up to 4 gig of character data. So another rule is a subquery cannot be immediately enclosed in a set function, and the between operator cannot be used with a subquery. However, the between operator can be used within the subquery. So subqueries with the select statement. Subqueries are most frequently used with the select statement. The basic syntax is as follows. So again, this syntax must be remembered and you must be familiarized with this so that it would be easy for you to write your SQL statements. So select column underscore name from table 1 where column name operator, and then parentheses, select column name from table 1 where. So we have here an example. Consider the customers table having the following records. So as you can see, we also uses the same table. So we have the column ID 1 to 7. Then we have name Ramesh to Mafi. Then we have age 35 to 24. And then address and salary. So now let us check the following subquery with a select statement. So our statement will be select asterisk from customers where ID in select ID from customers where salary is greater than 4,500. So in this particular statement, we will retrieve those customers whose salary is greater than 4,500. So from the original table, so we will be retrieving ID 4, which is 6,500, and ID number 5, which is 8,500, and ID number 7, which is 10,000. So the output that will be produced is 4, 5, and 7. In the SQL statement, so we uses the select asterisk from customers. So meaning we will be displaying all the fields in the customer table, such as the ID, the name, the age, address, and the salary. Okay. So subqueries with the insert statement. So subqueries can also be used with insert statements, and the insert statement uses the data returned from the subquery to insert into another table. The selected data in the subquery can be modified with any of the character, date, or number functions. So the basic syntax is as follows. So we have insert into table name, specify the column 1 or end column, select asterisk and then column 1 or column 2 from table 1 where value operator. So example, consider a table customers BKP with similar structure as customers table. Now to copy the complete customers table into the customers BKP table, you can use the following syntax. So we have insert into customers BKP, select asterisk from customers, where ID in, select ID from customers. So we are just going to copy the complete information and fields from the customers table into the customers BKP table. So we are just inserting the values. Next, we have SQL subqueries with the update statement. The subquery can be used in conjunction with the update statement. Either single or multiple columns in a table can be updated when using a subquery with the update statement. So the basic syntax is as follows. We have update table set column name is equal to new value. Where operator value, then select column name from table name where. So as you can see, after the where clause, we will be indicating an operator such as greater than, equal, less than equal, or not equal. So for an example, assuming we have customers BKP table available, which is backup of customers table. The following example updates salary by 0.25 times in the customers table for all the customers whose age is greater than or equal to 27. So our SQL statement will be update customers, set salary is equal to salary times 0.25, where age in, select age from customers BKP, where age is greater than equal to 27. So this would impact two rows, and finally customers table will have the following records. So using the original table with fields ID, name, age, address, and salary, where ID is from 1 to 7. So we are now going to get the name and the details of the customers whose age is greater than or equal to 27. So we have Ramesh, which is 35. So the salary is 2,000. So we're going to multiply 2,000 by 0.25. So which is 500. And then another customer, ID number 5, which is Hardik, 8,500. So we have 8,500 times 0.25, which is 2,125. So our output will be, there will be some changes or update with the values of ID number 1, which is 500, and ID number 5, which is 2,125. Next, let's proceed with SQL subqueries with a delete statement. The subquery can be used in conjunction with the delete statement, like with any other statements mentioned above. So the basic syntax is as follows. So we have delete from table name, where operator, specify the value, select column name from table name, where. So example, assuming we have a customer BKP table available, which is a backup of the which is the backup of a customers table. The following example deletes the records from the customers table for all the customers whose age is greater than or equal to 27. So our SQL statement will be delete from customers, where age in, select age from customers BKP, where age is greater than equal to 27. So we're going to delete. So this would impact two rows. And finally, the customers table will have the following records. So from the original table, whose IDs are as follows, 1, 2, 3, 4, 5, 6, 7. So we will be deleting the records of the customer whose age is greater than or equal to 27. So we have Ramesh and then we have Hardik. So the output will be ID 2, 3, 4, 6, and 7. So it satisfies the our condition that the age is greater than or equal to 27 only. Next, SQL using views. So a view is nothing more than a SQL statement that is stored in the database with an associated name. A view is actually a composition of a table in the form of a predefined SQL query. A view can contain all rows of a table or select rows from a table, and a view can be created from one or many tables, which depends on the written SQL query to create a view. Views, which are a type of virtual tables, allow users to do the following: structure data in a way that users or classes of users find natural or intuitive. Restrict access to the data in such a way that a user can see and sometimes modify exactly what they need and no more. It also summarizes data from various tables, which can be used to generate reports. So creating views. Database views are created using the create view statement. Views can be created from a single table, multiple tables, or another view. So to create a view, a user must have the appropriate system privilege according to the specific implementation. So the basic create view syntax is as follows. So we have create view, view underscore name as select column 1, column 2 up to the end column from table name where condition. You can include multiple tables in your select statement in a similar way as you use them in a normal SQL select query. So we have here an example. Consider the customers table having the following records. So we are just going to use the same table from the previous slides. So we have ID numbers 1 to 7, and fields like name, age, address, and salary. So following is an example to create a view from the customers table. So this view would be used to have customer name and age from the customers table. So we have the SQL statement create view customers underscore view as select name age from customers. So meaning that this particular statement will only view the name and the age of the customer. So it will display the name and age such as Ramesh 32, Kilan 25, Kaushik 23, Shaitali 25, Hardik 27, Komal 22, and Mafi 24. So that would be the output of this particular example. Next, now you can also query customers view in a similar way as you query an actual table. Following is an example for the same. So we have select asterisk from customers view, wherein we're going to display all the values in the table. So this will produce the following result. So this one. So the original table and our result. So we will retrieve the name and the age of the particular customer. So we will not include the address and the salary since our query only states that we only selected the name and the age of the customers. Okay. So now the with check option. So the with check option is a create view statement option. The purpose of the with check option is to ensure that all update and inserts satisfy the condition in the view definition. So if they do not satisfy the condition, the update or insert returns an error. The following code block has an example of creating same view, customers underscore view, with the with check option. So we have create view customers underscore view as select name age from customers where age is not null with check option. The with check option in this case should deny the entry of any null values in the in the views age column because the view is defined by data that does not have a null value in the age column. So in this particular example, all of the customers in the table indicates the value of their ages. So there are no null values inside our table. And then updating a view. So a view can be updated under certain conditions which are given below. The select clause may not contain the keyword distinct. The select clause may not contain summary functions. The select clause may not contain set functions. The select clause may not contain set operators. The select clause may not contain an order by clause. The from clause may not contain multiple tables. The where clause may not contain subqueries. The query may not contain group by or having. Calculated columns may not be updated. And all not null columns from the base table must be included in the view in order for the insert query to function. So updating a view. So if a view satisfies all the above mentioned rules, then you can update that view. So the following code block has an example to update the age of Ramesh. So SQL update customers underscore view set age is equal to 35 where name is equal to Ramesh. So this would ultimately update the base table customers and the same would reflect in the view itself. Now try to query the base table and the select statement would produce the following result. So we have Ramesh 35. Okay. So next, inserting rows into a view. So rows of data can be inserted into a view. The same rules that apply to the update command also apply to the insert command. Here, we cannot insert rows in the customers underscore view because we have not included all the not null columns in this view. Otherwise, you can insert rows in a view in a similar way as you insert them in the table. So next is deleting rows into a view. Rows of data can be deleted from a view. The same rules that apply to the update and insert commands apply to the delete command. So following is an example to delete a record having age is equal to 25. So our SQL statement would be delete from customers underscore view where age is equal to 22. So our condition is the operator that we use is equal. This would ultimately delete a row from the base table customers and the same would reflect in the view itself. Now, try to query the base table and the select statement would produce the following result. Okay, so let's see which age contains or which customer has an age of 22 or age is equal to 22. So we have ID 1, Ramesh is 35. 2 is Kilan, 25. 3, Kaushik, 23. 4, Chaitali, 25. 5, Hardik, 27. 6, Komal, 22. And ID number 7, Mafi, 24. So in this case, the our we will be deleting the customer's record whose age is equal to 22 and that is Komal. So in our output, we have ID numbers 1, 2, 3, 4, 5, and 7. So we will remove ID number 6 because our condition is equal to 22. Okay, next, dropping views. So obviously, where you have a view, you need a way to drop the view if it is no longer needed. The syntax is very simple and is given below. So we have drop view, view underscore name. So following is an example to drop the customers underscore view from the customers table. So we have drop view customers view. But be careful when using this dropping view, and also when using the delete rows into a view. So always remember that delete and drop must be used with proper guidelines and proper usage. Okay, so there you go. So those are just an additional um, notes from our previous discussion. So we just discuss a few things about applying DML in subqueries and applying database view. So again, we have SQL subqueries, which can be used with the select, insert, update, and delete statements, alongside with an operator such as equal, less than, greater than equal, less than equal, in and between. So we have also discussed some of the rules that subqueries must follow, and we have indicated the basic syntax of SQL subquery with the select statement, and then SQL subqueries with the insert statement, and then SQL subqueries with the update statement, and SQL subqueries with the delete statement. And then we also discussed the SQL using views, and how to create views. So using the create view statement. Then we also provided the syntax for create view. And then we have the with check option. So with check option is a create view statement option. Then we also discussed how to update a view, how to insert rows into a view, how to delete rows into a view, and how to drop views. Okay, so as a as per our discussion, I will be posting this lecture or these notes in our LMS announcement part, so that you can review the basics of SQL syntax and statements. So if you have any questions, do not hesitate to send a message through the LMS chat box, or you can also email me at kvdelara@amais.edu.ph. So if you have any questions, just send a message, okay? So again, thank you for listening. Thank you for attending our virtual class today. And I do hope that you have learned some important aspects of about database management system.